Hello and welcome to Cadence Design Systems Fidelity Tutorial Tuesday, where we show you how to set up and use a Cadence Fidelity feature in just a few minutes. Today, we are going to show you how to set up the rotation of a wheel in a sliding mesh method. For the sake of convenience, we are going to split this tutorial into two parts. In the first part, we are going to see how to split the domain into static domain and the rotor domain. In the second part of the series, we will see how to mesh these two domains and set up the case in the Fidelity LES Helmholtz moving solver. Through this method, we would be able to capture the rotation of the wheel in a transient manner while it is in contact with the static ground. To use the sliding grid method, you need a rotor-stator interface penetrating through the tire wall. This complexity imposes need for a special treatment in the domain split. Here, we have our surfer file open. In this, we are going to use a common surfer file to generate both the static and rotor domains. As you can see, the flow domain has been brought in STL format and the interface has been generated in the input file itself. Additionally, we have also changed the name of the generated interface from tcone to AMI, as you can see here. Once the surfer file has been opened using the surfer executable, we open the instance in the Charles Connect app. We can see the fluid domain and all the associated zones. After hiding the tunnel walls, you can see the AMI interface too. You can see from the tunnel walls that the silver side, which is the wetted side of any CFD domain, is on the inner side of the static domain. Also, both for the tires and for the interface, the wetted surface is facing outside. Therefore, we can directly go and create the static domain by intersecting the AMI surface with the tire surface. For intersecting, we will use the intersect zones option. As you can see in the command line, we have the intersect zone option typed in. Let me go ahead and complete the intersect zone command. I have entered all the four zones of the tire and I give a space and I give the AMI interface. Now I allow for the operation to complete. With this, the static domain of the tire rotation simulation has been generated. Let me hide the tunnel walls to show you how the domain has been generated now. Once you hide the AMI surface, you would be able to see that the inner surface of the tire has been carved out and only the exterior static surface has been maintained. After this process, you can go ahead to the surfer option, come to surface manipulation and export the geometry. Next, we are going to see how to extract the rotating domain. Let us start with executing the same surfer file. Now, let us go to the Charles Connect app and open the surfer instance that is running. We first hide the tunnel walls to be able to visualize the interior part of the tunnel. As you can see, the normals of the tunnel, the tire and the interface are facing outside. Since we have to extract the rotor domain, we have to flip the normals of the interface to the inner part. Therefore, we select the AMI interface, go to surfer, go to facet repair and we flip the normal for the selected surface. As you can see, the normal for the AMI interface is now facing inside with the golden surface facing the outside. Now, let us go and intersect the tire walls with the AMI interface. As you can see, the interior rotor domain has been completely extracted. You can go ahead to surface manipulation and export the rotor domain. In part 2 of this series, we will see how to mesh the two extracted domains and set up the case in Fidelity LES Helmholtz moving solver. If you like this video, be sure to click the thumbs up button or subscribe to our channel for more videos like this. If you have any questions, comments or suggestions, drop us a line below or connect with us via LinkedIn, which is linked in the description. Thank you all and have a pleasant Tuesday.